Hey everyone, thanks for tuning in this week. Last week we talked about a bird that is common in a lot of the United States, so this week we wanted to bring you a bird that you may not be as familiar with, the oilbird. The oilbird is a bird that lives in caves in South America. It's nocturnal and flies around at night, and uses echolocation to get around. Sounds like a bat, right? This episode is a wild one. Join John, Shannon, Amanda, and I as we discuss the oilbird. Grab your night vision binoculars, and let's get into it. Hey everyone, thanks for listening to Birds of a Feather Talk Together. This is RJ, and I'm here with Amanda and John and Shannon. And today we're going to talk about a bird called the oilbird. So last week we talked about a bird, the cardinal, that in a lot of places in the U.S. was very common and everybody had seen, but I think that this week we wanted to talk about something maybe people hadn't heard of, so we decided to talk about the oilbird, which for those of you that aren't familiar is a bird that lives in caves, and a lot of people compare some of its things to like a bat because they're nocturnal. I don't know, do you guys want to talk about the oilbird a little bit? Is there anything
I think oilbirds are one of the coolest birds of all species of birds.
Oh, awesome.
I mean,
I'm excited for this episode.
They echolocate, but the good thing for humans, unlike some bats, is that we can hear them. So you can hear the echolocation. Everything about them is fascinating. They look fascinating. Their story is amazing. The things they do, the role they've played in human cultures is really fascinating to me too.
And what do they, just for people that aren't familiar, what do they look like? Because if they live in caves, they don't look like bats, but they're kind of larger than I was expecting,
they're
right?
Definitely good-sized birds. That's one of the first things I think is really interesting. So they're from South America, from northern South America for the most part, although they have a really broad distribution through the Andes and across into the Tepuis in Venezuela and in the coastal mountains in Venezuela. And I would say they're about the size of a crow and a little slimmer and a little longer-tailed and longer-winged. And then, we've talked about bills when we were talking about martins. I mean, they're a lineage of the birds that are often called nightjars, in a sense, which is a big, very, very old clade of birds, and they're the first branch off, and they're the only species in the branch. Oh. And so one of the things Shannon was saying about an evolution novelty is early on in the evolutionary diversification of what eventually became not only nightjars but also hummingbirds and swifts, you had this split for a large fruit-eating nocturnal bird. Mm. And that was in South America. And I don't think there's any fossil record that implies that they get out of South America, but nothing would surprise me given how old they are.
Mm-hmm. Yeah, so we're talking about tens of millions of years, right? Wow. Maybe even 40 million years old. Some of that species is. So it echolocates. It feeds at night in the dark, and it has incredible numbers of rods in its eyes. I think when I was reading about it, it has the largest density of rods of any vertebrate. So it's designed for low light, but not designed for no light. So what they compensate for in these caves where there's really like no or almost no light is echolocate. So that's how they find where they're going, echolocation.
So it's a combination of using echolocation, and then once there's a little bit of light, then they're relying on their eyesight.
So they're a bird that I would like to see what they see at night, right?
And they're these different facets of their life history, which suddenly become really important, which is on the one hand, they're nesting in these caves which are total darkness, where they've got to go back and find their nesting site in a cave that may have 1,000 pairs of birds in it, so that they can be in caves that are really crowded. But then they're going out to forage, and they're flying along, and so if you think about it, these other nightjars and things that are feeding on the wing at night, those are looking for insects, whereas these birds are specifically looking for fruits, mostly palm fruits. Mm-hmm. And so that becomes a whole different mechanism, which I think plays into the reason there are so many rods, is it must, in the eyes, is it must be some kind of benefit to help them look at this forested landscape that they're flying out over, and they have these big long wings. They actually look like falcons when they're flying, in a big falcon, but they're able to fly long distance to find the fruit, and part of that's a evolutionary requirement because there are periods of time when that's really spotty. So you may need some really special adaptations to get really good at finding fruiting trees when you're above the canopy a little bit, foraging along trying to find it. I was wondering what kind of smells they have, because that's another possibility. And I would say that the closest thing to them from an ecological standpoint associated with the fruit in a lot of ways are fruit bats. And these are big bats that are often doing the same kind of thing. They live in colonies. They tend not to live in caves, but again, and they're in places like Africa, and there aren't actually super big fruit bats in South America, which is kind of interesting. Maybe that's competition with oilbirds
because of the
But
oilbird.
you can't go very far with the oilbirds without. Why are they called that, right?
Right.
So they're called that because culturally humans have the birds provision their young to where the babies can weigh like twice what an adult weighs when they're babies, and they were squeezed to get out the oil so they put on all this fat because it's not necessarily clear how frequently you're going to eat when you have that, so they provision the young pretty well, but they get really, really, really fat when they're babies, and they would use that to light lanterns and things like that.
It was specifically from the babies?
So they would
I didn't
squeeze the
realize
oil
that.
and use the oil for other purposes.
And actually the scientific name Steatornis is caripensis, is named after the town of Caripe, which is a city in Venezuela that has a big nesting colony above the city.
Okay.
And so that it goes way back, and as Shannon was saying, the cultural aspect of this is really interesting, and there's still a colony in Caripe today, and so it's been something that at least hasn't, I'm sure, has led to the deaths of thousands of chicks over the years, but at the same time the colony is still there, and again they've got a lifestyle which is incredibly unique, and yet at the same time pretty successful.
Yeah.
Yeah, they're not endangered as far as we know right now. They build, literally crappy nests. Nests are made of poop. So, yeah, which is interesting. So I looked at pictures last night of the eggs get dyed brown from the poop that they make their nest from. It's completely wild.
And then the chicks get larger than, they grow
they
larger.
weigh more. They weigh a lot more than their parents do.
And then how do they shed that weight? How do they get to the point? If you
they starve.
They have enough.
It's a combination of putting it into growth and producing feathers and things so that they can actually leave the nest.
Wow.
But that's
palm fruits have a lot of good nutrients, a lot of the right kind of nutrients to survive on.
So just.
And they're vegetarian, which is that's not that common for birds to be like that strictly vegetarian.
No, but I was going to point out one of my favorite birds in the world is something called palm-nut vulture from Africa, and it's a vulture that's taken to eating palm fruit. That's what they do, and so there are some other things. They're nowhere near as numerous or interesting as oilbirds in some level, but it is pretty amazing that you get these opportunities out there, and suddenly something realizes that palm fruit are something that you can actually exist on.
Wow.
Yeah. And we have 38 in the Field Museum's collection. So, and I meant to look, but do we have a pickle?
We might.
That's an alcoholic specimen.
Yeah, I think we do. We just did we were just part of our collection was used from some colleagues from the the Denver Museum of Natural History who are studying something called the columella, which is one of the bones in the ear of birds. And one of the birds that they really wanted to get was oilbird sampled, and we allowed them to go into the skeleton collection, and they go in with a pair of forceps and they can literally dislodge this bone, and they're looking at variation across all birds with respect to this, and you would expect, given how special oilbirds are in terms of what they're doing, that might be a really interesting thing, and they're just beginning to scratch the surface of that. So it's neat to have these other specimens like this. The one other thing I was going to say is I meant to look this up and I didn't get into the details of it, but the distribution of in South America of oilbirds is such that you might predict there would be some genetic structure, because it's fairly broad. There are ones up in Venezuela, and then there are ones down the Andes.
And they're really old as a species.
Right.
They're very old.
Right. And my recollection is the genetic data are not showing that they're very different in terms of their population structure. And part of that may be literally that birds are foraging so far that they're routinely enough getting lost and finding their way back to other colonies in different places, so that they maintain gene flow across a much bigger landscape than a lot of other things would.
One of the things that DNA has told us that was pretty shocking to me, was a study that we did 14, 15 years ago now, showed that hummingbirds and swifts, each other's closest relatives, are nested within the caprimulgiform birds. So they're nested within the family that or the order that has oilbirds. So, look at that. There's no wonder nobody knew these relationships, because these birds don't share anything.
Yeah,
right. They don't share behaviors. They don't share.
Yeah.
I mean, one of the fascinating things to me was historically they've been put next to one another.
But not inside.
No, not inside. No, not inside. But definitely next to one. Which but I'm interested that somebody thought there was actually reason to keep them close together.
Yeah.
Interesting.
Yeah.
When they're in caves, me and Amanda were wondering, like, do they share caves with bats in South America? Like, are there a point where, like, at dusk you can see, hundreds of birds and hundreds of bats all flying out?
That's a really good question. I'm going to guess the answer to that is yes. And that's a spectacle that everybody should see. I keep saying to people that, eBird has these rotating photos that they pull out of the collection of eBird photos that are coming in. And one of my favorite ones recently is of a red-tailed hawk in the middle of a big group of Mexican free-tailed bats that are coming out. And so that, one of the reasons why all these organisms do this is there's safety in numbers, and caves are really stable habitats for the most part.
Yeah, what makes a good cave?
Yeah.
I don't know the answer to that. So do you
Yeah.
have any idea?
Well,
What makes a good cave?
I think it depends on the species. There's actually some, that's an interesting, I should know more about that than I do, I think. But no, I think there's a lot of variation in how wet they are, how dry they are, and so humidity and that can play a big role in terms of how suitable they are for colonies of things.
Do they, with their crappy nests, do those ever get cleaned out and replaced, or is it this ever-growing?
They get to be, they tend to be very stacked.
Okay.
And so there is actually a level of, it may be that they're not, the same site isn't used every year, but over time those begin to definitely build up so that they're
Wow.
yeah, and I would love to see a group of those birds coming out at night from a cave, because that must be quite a sight.
Oh yeah. And then their call is very unique too, right? They got kind of a shrieking, scary sounding.
Yeah, they definitely make a lot of noise when they want to.
Oh yeah.
So everybody should go look at videos and find sound recordings of them, because they sound otherworldly in the way they vocalize.
I feel like that one of the things that's fruit bats are a little like that in places in Africa where you have the big fruit bats around too, that they are actually quite noisy in that sense. And that's
they shriek at each other.
Yeah.
It's really.
And is that just to communicate back and forth, or what are they trying to scare things off?
That's a really good question because
they don't have real like a lot of predators, right? I mean, they're fairly.
No,
Yeah.
what would be the information content of that scream? But
Yeah.
Well, it might have to do with their syrinx, the vocal producing organ.
Yeah.
Might have, that might be what comes out of a syrinx that looks like that, and I don't know the answer to that.
Yeah.
But we know people who do. And that's just not us.
The specimen that you get, are you able to study the eyes? If the eyes are so unique and have so many, is it so many rods or so many cones? I'm trying to
Rods.
Rods.
Yeah.
Is that something that you can study and take apart and look at, or?
Well, this gets back to whether or not there are specimens that are preserved in certain ways. And what I would say is most of our specimens, for instance, are probably collected back in the. I know we got a few specimens in the mid 2000s, but a lot of them are older than that, and those wouldn't have material like that. And so when you get interested in something like this, that's one of those situations where you really want to be able to go out and get new material that you're preserving in specific ways. So, for instance, we just gave a nitrogen tank to a graduate student from the University of Chicago who's studying butterflies. But coming back to what we were just talking about, one of the things he's studying in the butterflies is actually the RNA expression in their retinas. And so in order to do that, he needs really well-preserved material. And so we let him use one of our nitrogen tanks. He's down in Costa Rica right now. And the goal is to get that material preserved as well as possible for the samples that he's getting so that he can come back and look at that RNA expression. And, whoever did the work to figure out how many retinal or how many rods there are in these Oilbirds needed really good material in order to do that.
Yeah, and so normally if we're going to prepare a specimen as a study skin, we make an incision in the bird and we basically turn it inside out, take out everything that could rot and replace that stuff with cotton. So, birds don't have white eyes, but bird specimens almost universally have white eyes because we replace the eyes with cotton. There's a cotton brain, it's a cotton stick, and then a cotton body that goes in. And now I look at those things and I'm like, I wish we still had your parts. I really wish we had your eyes.
Eyeballs, yeah.
And I really, really wish we had your brain so that we could see what genes are being expressed in your brain and the same with eyes. But, we don't have that material now. But if we know that someone is studying these things when we go to the field, if we're in a place where some of those study specimens are, we will put on ultra-cold temperatures birds' eyes so that you can look at some of those things. But, museums don't look like they change very much. I mean, if you went and you pulled out a drawer and the birds from 100 years ago look really similar to the birds that might have gone in yesterday. But the amount of data that we take from each one of these specimens is a lot more, not just geography, but parasites, internal and external parasites. So something that John's calls the extended specimen, that about maximizing the utility of these things to provide details about biodiversity.
And then you mentioned earlier, you called it pickling as far as preserving something. Is that a practice that's still used, or is that, how's that different than what you're normally doing?
What I would tell you is that's a practice that was done in the past that kind of lagged off in the 1940s.
At least in birds.
A little bit. I mean, not everywhere.
Okay.
But it's beginning to come back, and I don't want to say we're seeing the error of our ways, but we're seeing the value of having more pickled specimens. And so we have a National Science Foundation grant where we're partnering with a whole bunch of different institutions who've been scanning vertebrates using CT scans, which was something that wasn't even imaginable back in the 1950s and 60s. I mean, we're literally the last 20 years has just revolutionized our capacity to look at morphology using CT scanning. Well, you need pickles for this, and my recollection now is that actually they did pickle a Oilbird on an expedition in Peru back in the early 2010, 2015 or so. And that specimen suddenly becomes really important for looking at comparative anatomy questions across these groups, and we've CT scanned that, and that CT scan has been made available through this open data portal called Morphosource in a way that anybody can download it and start looking at it, and those are really valuable things to do, and a bird like Oilbird is a great example of something that's so ecologically specialized and has such an amazing natural history that it becomes something that's really interesting to look at in those kinds of details. And I don't think we've even begun to scratch the surface of the kinds of things that, what does it mean to your digestive system if all you're eating is fruits is likely to be very different than a similar related group of birds that's only eating insects, and what's the ramifications for your physiology if that's all you're getting out of your diet and it's really high in oils. Well, there's all kinds of stuff that eventually people can begin to study, and having those specimens like that is a starting point to get those people looking at those things.
I mean, now we can study brains from pickled specimens because we have the technology. So these super speciating kingfishers on islands, we can ask, what happens to their brain? Can we know how brain changes are playing a role in the diversification of some of these lineages of birds? And you need pickles to do that because the brain is, get that information from the outside of the skull of these birds.
Coming back to Oilbirds, what's their spatial memory capacity? Like, can they actually find trees that are in the forest on multiple nights? My guess is probably yes. How do they do that? Well,
yeah, so their brains there are parts of their brains that may be more developed, and that you could see that through CT scanning.
Okay.
When you look at variation. We just don't know enough about these things yet to know.
Wow.
Yeah.
We didn't think birds smelled very much before, but now we know that that's not true, that their olfactory lobes are very well developed. Now that we can study brains, we can look at the variation in that across birds.
Yeah.
Is there a bird like the Oilbird is known for, having such good sight at night? Is there a bird that we've learned has like the best scent, like that can smell very well?
The classic one is turkey vulture.
Oh, really?
Which is really interesting. So what they realized was turkey vultures can actually smell rotting carcasses and things, and so they're flying around picking up those smells. They took advantage of it. So there were these large natural gas pipelines across the southwestern U.S., and every once in a while they would spring leaks. And somebody came up with the idea to put in a little bit of beta-mercaptanol, which is a compound that comes out of rotting flesh it's one of the things that the turkey vultures pick up on. And so then they could actually find gas leaks in these long, 100-mile long gas lines by simply watching where the turkey vultures were coming in.
That's so
That's
cool.
awesome.
It's a great way to take advantage of something that they're doing naturally.
So smart. That's so cool.
Well, I think that might be a good point to jump into one of our mailbag questions. So this is from Nav from West Sacramento, California. And she says, I was lucky enough to have a hummingbird hatch 2 eggs within eyesight of our kitchen window. She made 3 nests on a string of outdoor lights. Only one of the nests had eggs which hatched. The other 2 seemed to have been backups. Is this typical for birds to make more than one nest? Was she perhaps planning to lay more eggs? Wondering why a bird would make multiple nests in the exact same area.
Yeah, that is a cool question, and what a neat thing to get to see in your yard,
I
in my
know.
opinion.
Yeah.
So I don't fully know the answer of why that bird built 3 nests. And
Seems a little overkill.
maybe,
I mean, you would
practice.
nest if it failed, right? If your first one, hummingbirds lay 2 eggs, 2 little tiny white eggs, and you would think that if it failed, and they will immediately try to build a new nest, but there's a lot of energy that goes into building hummingbird nests. This is not just using your poop. It's a lot more that's going into that.
They bring in lichens and spider webs, and
They're decorated.
structurally really sturdy little things, and so that's I wonder I wonder what the.
Do you think maybe there was more birds than she knew?
Oh,
And
yeah.
so there were other birds that build nests, and those nests didn't succeed. But sometimes it's not easy to know how many hummingbirds you have in your yard or around. I don't know, though. That's awfully close. If they're on the same wire in her
Yeah.
yard.
Yeah,
I don't
that's
know.
so
think
cool.
That for some reason, I think that happens sometimes. And
Well, there's variation, right?
Mhm.
So that's the rule of biology.
Yeah.
So that almost nothing is fixed without variability.
Yeah.
So maybe she did it because she could.
Yeah.
maybe
Yeah.
there's something that gets into hummingbird nests like that makes them unsuitable to raise chicks in. So there's a parasite or something. I don't know whether anybody's looked at that.
It's not like they can't move the eggs. You know, you can't like, oh, this one I'm not so sure about. I'm going to move them to the next one.
Yeah.
That is not going to happen.
Mhm. Yeah.
But-
That's so cool.
All right. Well, I think that's it for today then. So thanks everyone for listening. John, you want to wrap it up?
Yeah, I think everybody should make a trip to Venezuela and look for oilbirds because they're incredible to see.
Thanks everyone for listening, and thank you to Earhole Studios in Chicago for hooking us up with a place to record. They're the best. If you have a question for John, Shannon, Amanda, and I, feel free to send it to podcast.birdsofafeather@gmail.com or reach out to us on Instagram. We're going to be off for a couple weeks, and then we'll be back with some fresh new episodes in mid-August. We have plenty of great episodes in our library for you to check out. If you haven't listened already, go back and check out some older episodes where we discuss the frigate bird, the great horned owl, the birds of paradise, the purple martin, and many more. Two of my favorite episodes are the sandhill crane and the American woodcock. There's plenty to listen to, so please check them out. Hope everyone is enjoying their summer. We'll be back soon with more episodes, and thanks for listening.